at 1. Okay, it should go up sort of like that. And then we have a quadratic function. Another puppy needs to be let in. Oh, that's not a puppy. That's a kid. And we need to take this quadratic, and we're going to plot this. It has a leading coefficient that is positive. It's going to go up, and we're just kind of guessing what it looks like for now. But what you would want to do is you could either, as we said, set x plus 1 equal to x squared minus 2x minus 3 and solve for those x values. Or you can just go ahead, if it's calculator active, you can graph each of those functions, x squared minus 2x minus 3. And you should see what they both look like. Okay, so our picture wasn't too bad. It looks like they intersect more on the x-axis there, so you can do a better picture than I did. But we're going to calculate our intersections so that we know where our functions actually intersect. So our first one is at -1, 0. So this, we're going to make a really big dot to make it look like it's on the x-axis. So at x equals -1 is where our first one's going to be. Calculate our second intersection. So first curve, second curve, and then we do want to care where we guess for these because, oh, I'm so sorry, because your calculator needs to have a general area since there are 2 intersections. So this one's going to intersect at x equals 4, okay? And we're looking for the area between these two guys. Okay, so our limits of integration for this are going to be -1 and +4. Remember, -1 is smaller, so it goes on the bottom. 4 is bigger, so it goes on the top. And then we want to look and see which function is on the top and which function is on the bottom. So this line is the one on top. It's like the upper bound of these two things. And the quadratic or parabola is the one on the bottom. Okay, so we want to take the top because it's going to have like a bigger area. We want to subtract the bottom off from it. So it's saying that we want to take, maybe this will work, all of the stuff that's beneath the line and then subtract off all of the stuff that's beneath the parabola, okay? And so we're left with just that little pink region in between, okay? So we want to take x plus 1. We want to subtract off our parabola, x squared minus 2x minus 3, and all with respect to x, okay? Let's go ahead and simplify this just for my sanity, I guess. Negative x squared, this becomes positive, so we would have plus 3x, and then we would have positive 3 here, plus 1 would be 4 dx. And now at this point, since we've done so many algebraic ones, let's go ahead and use the calculator again. You can put in this one or this one, and you'll get the exact same thing, okay? So I'm just going to do the first one to be safe. So we would want to put in x plus 1 minus x squared. We want parentheses because we're subtracting the entire thing, minus 2x minus 3. And we want to, I mean, you don't have to graph it, but there it is. Click second, and you might be asking, Miss Roberts, why does our parabola look different? And it's because we're not graphing this, okay? We graphed that before, and we graphed it as 2 separate functions. This becomes one function when we subtract one from the other, so it comes up with something that's totally different, but it will still have the same area in the region that we picked. So we do second trace to get our integral function. Our lower limit was -1. Our upper limit was 4. Click enter. Oh, and we should get 20.83 repeating. Okay. But it's nice to be able to have the fraction. So quit out of that, click second answer. You'll get our value from before, math enter, and you should get 125/6 units squared as your final answer. I will say that if it is calculator active, obviously I'm totally fine with you putting the decimal really at any, well, if it's not calculator active, I would be very surprised if you were using a decimal and I would suspect that you were cheating. But if it's calculator active, go ahead and use the decimal. It's not a big deal. Okay, so there's those examples. Good luck with the whiteboard practice. Send me questions on that, and then I will make a new video answering your questions. I hope you guys have a great day.